Okay, in this video we're going to talk about scientific notation. So scientific notation is kind of a shorthand for numbers that are very, very large and very small, which often are used in science, which is why it's called scientific notation. So the idea is that you write numbers as some sort of number, which is often called the coefficient, times a power of 10. So the number here has to be between 1 and 10. Okay, so the coefficient has to be between 1 and 10. So basically you want one digit and then a decimal place. And then the power is whatever number of places it takes to move that to get it where it needs to be. So let's look at a few examples. 1, 2, 5. So 1,250,000. Also, just as a little reminder, so 100 is 10 squared, 1,000 is 10 cubed, just powers of 10. So however many zeros you have, it also goes with the power of 10, which is helpful for scientific notation. It also tells you how many places you move the decimal. So here 10 is 10 to the 1. So for example, if I do 5 times 10, I move the decimal one place, I get 1 0. If I have 5 times 100, I move the decimal twice, okay, and so on. So however many zeros here is however many places you move the decimal. If I'm multiplying, this is adding zeros, but if I have like 2.5 times 10, I move the decimal once. If I multiply by 100, I move the decimal twice, and that gives me, I have to put in a 0 to fill that place, and so on. So the exponent here is the number of zeros on the 10, but when you're looking at other numbers, it's how many times you move the decimal place. All right, so here, I want to put this into scientific notation. So I want to have a number between 1 and 10. So that means I want the decimal place to go here between the 1 and the 2. I want one non-zero digit to the left of the decimal. So that means I'm going to have to move 1, 2, 3, 4, 5, 6 places. So that is going to give me 1.25. Okay, I can drop all of the zeros times 10 to the 6th. I moved it 6 places. If you have a positive exponent, it came from a big number. If you have a negative exponent, it came from a little number. Okay, so remember what we just did with exponents. If you have 1 over 10, that'd be 10 to the negative 1. 1 over 100 would be 10 to the negative 2. Remember, a negative exponent means a reciprocal, and that's going to move the decimal the other direction. So if I do 2.5 times 10 to the negative 1, that's going to move it one decimal place smaller. Okay, so negative exponents go with a smaller number, positive exponents go with a bigger number, just like you'd expect. All right, so let's try it. So this one would be 1.25 times 10 to the 6, big exponent. Let's say we have 0.000346. Okay, so first figure out where you want the decimal to be. I want the decimal to be here. So I have 3 point whatever. That gives me a number between 1 and 10. And then figure out how many times you have to move the decimal place. 1, 2, 3, 4. 4. So I would have 3.46. And I moved it 4 times from a small number. I moved it 4 times to the right. That would be a negative 4. Okay, so negative 4 goes with small, or negative goes with small numbers, positive goes with big numbers. If you have a number in scientific notation and you need to fix it, so let's say we've got 34.7 times 10 to the 6. Okay, so this is in scientific notation, but it's not right because that's 34, and I need it to be between 1 and 10. So I need the decimal place to be here. Okay, so I am making the number smaller, the coefficient smaller. So I'm going to get 3.47 times 10 to the, and then really the only hard part here is you have to decide if you're adding to the exponent or taking away from the exponent. So this was a big number, so I'm going to add to the exponent. So 34.7 was a bigger number. If you want to think of it in terms of moving it to the left and to the right, and that works for you, I get that mixed up too much. So I just think of bigger number, smaller number. So 34 was a bigger number, so my exponent's going to get bigger. Let's say we have 0.02 times 10 to the 9th. Okay, so I need to move this to here. So I have 2.0. So that means I'm going to move it 2 places. So you'd either write 2 or 2.0, just depending on, both would be right, depending on if they want you to have a decimal place there. Times 10 to the, and I moved it 2 places, and it came from a smaller number. So I'm going to make this smaller. Okay, so if it came from a bigger number, exponent gets bigger. If it comes from a small number, exponent gets smaller. Oh yeah, let's do one that's negative. So we'll come over here. Got 2 more. All right, so let's say we've got 427.8 times 10 to the negative 5. Okay, so got a scientific number, but it's not the right format. I need the decimal here, so I need to move it 2 times. So I'm going to get 4.278 times 10, and then this was coming from a bigger number. So my exponent is going to get bigger by 2. It's still going to be negative, but it's going to get bigger. Okay, so it gets bigger by 2. It goes from -5 to -3. All right, so negative exponents work the same, moving left and right. And then the last one is if you have, let's say you have a number that you don't need to modify because it's already between 1 and 10. If you have to write it in scientific notation, you would write it as times 10 to the 0. Because remember, anything to the 0 is 1. So if you, for some reason, had to write this in scientific notation, like to put it into a spreadsheet or something, the exponent would be a 0 because it's 2.54 times 10 times 1, and that doesn't change anything. Okay, so that's all on formatting for scientific notation. So now let's look at some of the operations on scientific notation. So we want to be able to multiply, divide, add, and subtract if we can. All right, so let's say we've got 3.4 times 10 to the 4th. And we're going to multiply that by 1.8 times 10 to the 5th. Okay, this is all multiplication. So what I can do is I can rearrange. I can do 3.4 times 1.8, and I can do 10 to the 4th times 10 to the 5th. I can group these in the way that makes it easier to multiply. So hold on one second. I have an answer written down here, but I don't think it's right. 3.4 times 1.8. Okay, good thing I looked that up because that wasn't right. So I would have 6.12. Okay, so when I multiply these two numbers together, I get 6.12. And then when I multiply the tens together, I just have to add the exponents. Because remember, if the bases match, you add the exponents. So I get 6.12 times 10 to the 9th. And then I have to double check that this number out front is still in scientific notation. And it is. We don't have to reformat this one. Okay, so that one's good. Okay, so for multiplication, just rearrange. Multiply the 2 decimals, multiply the tens, which just means add the exponents, and then check to see if you need to reformat. All right, dividing. Let's say we've got 2.6 times 10 to the 8th and 6.5 times 10 to the negative 4. And you might be thinking, why wouldn't you just change these and put them in your calculator? When the reason why we do these is because when the exponents get really big, your calculator doesn't have that many decimal places. So unless you're on like a computer, you need to have some way to be able to calculate these. Okay, so same idea here. Because this is all multiplication and division, we can group it. So we can do, like, you have 2x over 6x. You can do the numbers and you can do the x's. So we're going to do the same thing. We're going to do the decimals like this, and then we're going to do the tens. So I'm going to do 2.6 over 6.5. And then the tens, remember when you divide two things with the same base, you subtract the exponent. Okay, so it's 8 minus -4. I'd actually be adding. So 2.6 over 6.5, I get 0.4. times 10, and then this would be 10 to the 12th. Okay, so just like up here, we multiply the decimals, add the exponents. Here we divide the decimals and subtract the exponents. Now on this one, we're not in the right format. We need to reformat this. So I need the decimal place to be here. So I need to move it by 1. So it's 4 or 4.0 times 10 to the, okay, now we're going from a smaller number up. So I am going to subtract 1 from the exponent. So I get 10 to the 11th. Okay, so multiply and divide and check to see if you need to reformat your answer. All right, now addition, subtraction. Let's do this one. So 3.4 times 10 to the 5th plus 2.68 times 10 to the 4th. Okay, now before we do this, I'm going to show you what this looks like without scientific notation. Over here, we can multiply and divide because multiplication, exponents, division, those are really all the same thing. But over here, we're trying to add. So what we actually have for the for the first number, we move that decimal place 5 times. The first number is actually 340,000. And the second number, we move it 4 times. We're going to have 26800. Okay. And again, if the numbers are small enough, you could just convert it to regular numbers and then back again. But what I'm trying to show you here is that I can't just do 3.4 and 2.68 because the 3 and the 2 are not in the same place. They look like they are in the scientific notation, but they're not actually in the same decimal place because the 5 exponent is different from the 4 exponent. So what you have to do is you have to get these to the same exponents, then you can add them, then you can convert it back. All right, so I think it's easier to go down to the smaller exponents because that makes your numbers bigger. So what I mean by that is I would make this 34 times 10 to the 4th. Okay, so I move it over 1, and then 2.68 times 10 to the 4th. Now they're the same. Now they're like in the same decimal places, and I can add them. So I can add 34 and 2.68, and I get 36.68 times 10 to the 4th. And then what I might have to do is convert it back to the right place. So I need to move this decimal place back, and I get 3.668 times 10 to the 5th, because this was a bigger number going to a small number. And if you look here, 1, 2, 3, 4, 5, I got the same answer over here. Okay, so for addition or subtraction, you have to do something to the exponents to get them to the same place value. Then you can do the addition or subtraction. It doesn't matter if you go to the higher number or the lower number as long as they match. So let's do one more. Let's say we have 4.2. Let's see if I can fit this in before the video cuts out. Minus 2.5 times 10 to the 5th. So I'm going to convert these both to 10 to the 5th. So I'm going to move this 2 times. Okay, so I move the first one 2 times. And I get times 10 to the 5th for both. Then I can subtract. So I do 420 minus 2.5, I get 417.5 times 10 to the 5th. And then I need to get this back into the right notation. So I get 4.175 times 10 to the, and that's going to add 2 because it's a bigger number. Okay, so times 10 to the 7th. All right, but the key is whatever exponents you get, they've got to be to the same. And you can just convert them to regular numbers and convert back again. But if they're really, really big, or if you have multiple ones, that might take you longer. Just make sure that whatever you do, they're matching. You've got the right decimal places. Okay, and that's it for scientific notation.